Welcome to our video series on an operating system. In this video we cover storage structures, types and characteristics, microprogramming roles and functions, storage device levels and trade-offs. A storage structure is a computing refers to a way of organizing, managing and storing data in a computer system so that it can be efficiently accessed and modified. Storage structures can be based on the type of data being stored, the operations that need to be performed on the data, and the specific requirements of the application. They are essential for the data management in database, file system, memory management, and various other computing tasks. In this image, we can see the storage device processing. The some common types of storage structures includes arrays, a collection of elements identified by index or the key, typically of the same data type, is called array. Linked list, a series of nodes each containing data and a reference or the link to the next node is in the sequence is called linked list. Stakes, a collection of elimination elements that follows the last in first out is called stakes. A collection of elements that follows the first in first out is called the queues. A hierarchical structure with a root element and sub-element or the children, such as binary tree, AVL trees and B trees. A set of nodes connected by edges which can be used to represent networks are called graphs. A structure that maps keys to the value to efficient lookup called hash tables. Files and database structure storage system to manage the large amount of data, often supporting complex queries and transactions. Each of these storage structure has its own advantages and disadvantages and ideal use cases depending on the specific need of the application. Difference between primary memory and secondary memory. Primary memory is used for temporarily storing data that is actively being used by the computer CPU, while secondary memory storage is used to long-term data storage such as files, programs that are not currently in use. List below are some other primary and secondary memory differences. The memories are two types. There are primary memory and the secondary memory. In the primary memory there are ROM and RAM. In secondary memory is always the external source of memory. The primary memory is the internal source of memory. In the secondary memory, there is a CDs, DVD, flip, hard disks, and etc. The compare the, by the in this we can compare the difference between primary and secondary memories with, from the various parameters. In the storage, coming to the storage validity, primary memory is the main memory and stores data temporarily. Secondary memory is the external memory and stores data permanently. The CPU can directly access the data. The CPU cannot access the data directly. Primary memory is volatile, it loses data in case of a power outage. Secondary memory is non-volatile, data is stored even during power failure. Data is stored inside costly semiconductor chips. Data is stored on external hardware devices, links and hard devices on disks, etc. It can be divided into RAM and ROM. They do not have such classifications. Secondary memory are permanent storage devices like CDs, DVDs, etc. The speed of the primary memory is very fast compared to secondary memory is very slow. It takes it saves the data that the computer is currently using. It saves various types of data in various formats and huge sizes. Here we will discuss the various types of storage devices. Storage devices are hardware components used to store and retrieve digital data. They come in various forms and other designs to meet different storage needs in the terms of capacity, speed, probability, and duration. Here are some common types of storage device. Hard disk hard disk drives HDDs. Description: traditional storage devices that are used use spinning magnet disk to read and write data. Capacity: the range from hundreds of gigabytes GB to several terabytes. Speed: generally slower than hard disk drivers are generally slower than SSDs with with speed typically around 100 to 150 MB per second. Use cases: suitable for large-scale storages need where speed is not critical, such as for desktop servers and other storages. Solid-state drivers: the storage devices that use flash memory to store data with a moving parts. Ranges from hundreds of gigabytes to several terabytes. These are much faster than HDDs, its speed often exceeding 500 MB per second and up to several GBs per second. Ideal for application requiring high speed and performance such as operating system, gaming, and video editing. Hybrid devices combine the large storage capacity of HDDs with the high speed performance of SSD. Typically, several the capacity is typically several terabytes with the small SSD case, usually 8 to 32 GB. Coming to the speed, it's faster than the traditional HDDs due to the SSD cache, but not faster than as pure SSD. Use case suitable for users who need a balance between storage capacity and performance, such as general purpose. Coming to the USB flash drivers, they are portable storage devices that connect via USB port and use flash memory. Coming to the capacity, there ranges from a few gigabytes to several hundred gigabytes. Coming to the speed, varies widely depending on USB variations. USB 2.0, 3.0, 3.1, etc. are the variations of USBs. Use case: ideal they are used for ideal transforming files between computer, temporary storage, and portable backups. Memory cards: small portable storage devices which primarily in cameras, smartphones, and other portable devices. The types of memory cards are SD cards, micro SDs, the compact flash, etc. The capacity there ranges from a few gigabytes to several terabytes. Speed: coming to the speed, there are various wide based on classic type, example UHS, UH1, UHS2, etc. Use case: used for expanding storage in portable devices and for the data transferring between devices. Optical discs: storage media that use lasers to read and write the data. The types of optical devices are CDs, DVDs, Blu-ray discs, etc. The capacity of CDs are up to 700 MB, DVDs are 8.5 GB, and the capacity of Blu-rays are up to 128 GB. The speed is generally slower access speed compared to HDDs and SSD. They are they are suitable for media distribution, software installation, and archival storage. Network attached storages. The storage device that are connected to network allowing multiple users and devices to access data. The capacity of a network attached storage um, varies widely, often scalable with multiple driver base. The speed is dependent on network infrastructure and NAS hardware. They are used for small to medium sized business, home networks, and media streamings. The cloud storage. Online storage service provided by companies like Google, Amazon, and Microsoft. The capacity the capacity are virtually unlimited depending on the service plan. Speed depends on internet connection speed. Use case suitable for remote access, data backup, and collaboration. External hard devices. The external hard drivers. There are portable HDDs or SSDs that connect via USB, Thunderbolt, or other interfaces. The capacity ranges from the hundreds of gigabytes to several terabytes. The speed is similar to the internal HDDs or SSD depending on the driver type. They are used for backup, additional storage, and transferring large files. Each type of storage device offers distance advantage and is suitable for the specific scenario. The choice of the storage device depends on the factors such as required capacity, speed, probability, and cost. Microprogramming definition and roles in computer architecture. Microprogramming is a technique used in computer architecture where a sequence of micro instructions control the internal operating of the CPU to execute high level machine instructions. It serves as an intermediary layer between the hardware and the machine instruction, simplifying the design of the control unit. How microprogramming control the instructor executes. Micro Microinstruction sequencing. The control unit contains a microprogramming count at the point of the current micro instruction execution. Each micro instruction specific elementary operation like reading from a register or performing an arithmetic operation. Control signal. The micro instruction generate control signal to manage the data path, ALU operations, and other internal CPU components. Fetch, fetch, decode, execute cycle. The microprogram directs the fetch, decode, and execute the phase of instruction program processing. Advantages and disadvantages. Advantages: flexibility, easier to modify and update the control logic by changing the microphone. Simplified design reduces the complexity of the design that control control unit. Easier fixes. Error in the instruction implementation can be fixed by updating the microcode. Facilitates complex instruction, simplifies the implementation of the complex machine instruction and new instruction sets. The disadvantages: slower performance can be slowed than handwriting control due to the additional layer of interception. Increased hardware requirement required additional memory to store the microcode. The complexity in optimizing the microcode for performance can be complex. Storage devices. In the first slide, I showed the image of the storage device. The definition and importance of the storage device are: the storage device refers to a layered organization of various storage types in the computer system, arranged by the speed, cost, and capacity. This is crucial for optimizing performance and cost efficiency in data storage and retrieval. Levels of storage: registers, the speed, the fast, the speed coming to the speed in the registers. The fast storage type as the direct accessible by CPU, capacity very limited, cost most expensive per byte. The usage case: storing temporary data for CPU operations. It is used. Cache memory: speed faster than main memory but slower than register. The capacity is limited. The cost is expensive per byte but less so than the registers. Storing frequency accessible data on instruction to speed up CPU performance. Coming to the main memory, that is RAM, the speed is slower than the cache but faster than the secondary storage. The capacity is moderate. The cost is cheaper per byte compared to the cache. Use case: storing data on programs that are currently in use. The secondary storage, HDDs and SSDs. The speed is slower than the main memory. The capacity is high. The cost is much cheaper than the RAM per the byte. The use case is long-term storage of data and programs. The tertiary storage, optional disk tape devices, drivers. Speed much slower than the secondary storage. Capacity is very high. The cost is very low per the byte. The use case, it's used for backupping and the storages. The cloud storage, the speed depends on the internet connection. The cost, it's variable, typically based on the use case, remote access, backup and collaboration. The capacity, it's virtually unlimited. Trade-off between different levels: speed versus capacity. Higher level in the hierarchy registrations catch offered the high speed but the low capacity, lower levels. The secondary storage, tertiary storage offer the high capacity but the low speed. The cost versus performance: higher level are more expensive per byte but provide faster access time. Lower level are cost efficient for bulk storage but have the slower access time. Optimization: using system utilize the heirarchy to balance cost and performance, storing critical and frequently accessed data in the faster, more expensive storage, while less frequently accessed data in the storage in slower, cheap, cheaper storage. Understanding and effectively utilizing the storage device allows for efficient data management, balancing speed, cost, and capacity to meet the needs of the different applications and workloads. Thank you for watching my video. Please like, share, and subscribe for the more content. Thank you very much.